Hey guys, Mr. Mackey here. And yesterday we introduced you to differentiation and I set you the challenge to differentiate this equation. So, let's do it. We have x to the power 4 here, and what we do is we firstly multiply the indice by the coefficient. So this becomes 4x. But then what happens to the indice? It goes down by 1, so it becomes 4x to the power of 3. For this one we have negative x to the power of negative 2. So we multiply negative 2 by a coefficient. So negative 2 times our negative 1 would become just x. So what would our indice become? Well, we're taking away 1, so it would become negative 3. Now we do our 6x. So we multiply it by the power, so it becomes plus 6, and it's x to the power of 0, which is 1, so we just leave it as 6. Now that 9 is the same as, well, negative 9 times x to the power of 0. So we multiply it by 0, so we just leave that blank. So this is the differentiated version of this equation. 4x cubed plus x to the power of negative 3 plus 6. Today we're actually going to be using our differentiation to find the gradient of certain lines when we know the coordinates. We'll get to this coordinate in a minute. The first thing we have to do, regardless of what the coordinate is we have to differentiate. So let's do it. Y equals 4x squared plus 6x plus 1. When we differentiate it, this would become dy over dx equals 8x plus 6. That's the differentiated version of this equation. Now, how do we find the gradient? Well, we substitute the x value in our coordinate into this equation. So we do 8 times 3 plus 6. 8 multiplied by 3 is 24, plus 6 equals 30. So the gradient of this equation is 30. So what about this one? Well, let's differentiate this equation. 4x cubed differentiates becomes 12x squared. 2x squared differentiated becomes just 4x. And our 6x when differentiated becomes just plus 6. Now we can substitute our negative 1 in there. So we do 12 times negative 1 squared plus 4 times negative 1 plus our 6. Negative 1 squared is just 1, so 12 times 1 squared is, well, 12. 4 times negative 1 is negative 4 plus 6. So when that's all tidied up, that becomes 14. So the gradient of this equation is 14. It's pretty simple when you think about it. You just need to remember to differentiate it and just substitute the x value in. Let's do one more before our challenge. Now I have this equation here. Let's differentiate it. So we write dy over dx, and this becomes 4x. This becomes, well, it's because it's the power of negative 1, it's negative 3 to the x to the power of negative 2 plus 5. That's the differentiated version. Now let's substitute our negative 3 in there. So 4 times negative 3 minus 3 to the power, brackets negative 3 to the power of minus 2 plus 5. Now 4 times negative 3 is negative 12. Now this is probably the difficult one. Negative 3 to the power of negative 2 is actually 1 over 9. It's basically the squared as a fractioned form. So this becomes negative 3 times 1 over 9 plus 5. Let me tie this up a bit more. So negative 12 plus 5 is negative 7. Then we do negative 3 over 9, which is the same as a third. So the actual answer is negative 7 and 1/3. That's the gradient of this equation. Now, it's time for your challenge. Let's see how you do. So here is your challenge for today. I have the equation y equals 4x cubed plus 2x squared plus x plus 3x to the power of negative 1. And I have the coordinates 1 and 10. I want you to create the equations of two lines where the gradient is parallel to this and the gradient is perpendicular. So I want you to do one line where the gradient is parallel and one that's perpendicular. What do you need to know to make it work? How does it work? I'm intrigued for what you're going to do. I'm looking forward to seeing the results. Let's bring on more of this, and tomorrow we're going to move on to something a bit different. So good luck, take care, see you tomorrow guys.